The firing begins without a turn. The B-24 Liberator holds its heading over the Bismarck Sea. 4 engines locked into a steady rhythm, the nose pointed into a sky that offers no contrast and no warning. The pilot does not bank. The tail does not swing. No one twists in their seat to search for shapes behind them. The first burst leaves the aircraft without confirmation. Tracers stream backward into empty air, measured seconds earlier. To anyone watching from another plane, it would look like waste. Ammunition spent without provocation. A defensive gun firing into nothing. Then something peels away from the sky. Not trailing smoke, not tumbling violently, just separating from formation and falling, as if the equation holding it aloft has been quietly canceled. Inside the Liberator, no one reacts. The pilot keeps his hands steady on the controls. The tail gunner does not celebrate. He resets his stopwatch and waits. Another fighter enters the space the bomber has already passed through. Another burst follows, again without looking back. This one disintegrates. Later, intelligence officers will struggle to describe what happened. Reports will argue over whether 5 fighters were destroyed or only 4. Witness accounts will conflict. What will remain consistent is the detail that unsettles everyone who reads it. None of the kills involved visual tracking. The aircraft was named Blind Faith long before anyone understood how literal the name would become. It was an older B-24, patched and repatched, assigned to long reconnaissance and supply denial runs north of New Guinea in late 1943. Missions where escort was unreliable and visibility rarely cooperative. Its pilot, Captain Thomas Reeves, was not the sort of man people expected to innovate under fire. He did not look like a gambler. He did not speak like a risk-taker. He spoke carefully, quietly, as if every sentence had already been measured. They called him Clockwork behind his back. Not because he was fast, but because he was precise. Reeves had grown up in Akron, Ohio, far from oceans and airfields. His first job had not involved flying at all. He had worked in a rubber factory as a production timer, responsible for measuring output down to the second. Conveyor speeds, press cycles. Delays caused by vibration, temperature, friction. His work had taught him something most people never learned. Machines always told you what they were doing, if you learned how to measure the right thing. When he joined the Army Air Forces, Reeves carried that mindset with him. He was competent in training, but unremarkable. He did not push limits. He did not impress instructors. His evaluations noted calmness and accuracy, followed by a line that appeared more than once. Lacked aggression. Bomber units suited him. Bombers were not about aggression. They were about endurance. They were about surviving long enough for the numbers to matter. Over New Guinea, numbers mattered constantly. Japanese fighters were faster, lighter, and aggressive. They attacked from predictable angles and predictable distances because doctrine rewarded commitment. Bombers were expected to wait, to confirm, to react. Reeves noticed something different. He noticed that pursuit followed mathematics long before it followed instinct. A fighter approaching from the rear had a limited number of options. Its closure rate depended on relative speed, angle, and throttle setting. Once committed, that closure rate changed very little until the moment of attack. Most gunners waited to see the fighter before firing. By then, the equation had already resolved itself. Reeves began writing down intervals, seconds between first engagement and first burst, seconds between commitment and overshoot. He calculated relative velocities using airspeed, altitude, and known enemy performance. He treated pursuit as a problem already solved once variables were known. The tail gunner on Blind Faith learned to count, not by sound. Sound was useless. The engines drowned everything else. Instead, he learned to feel the vibration of the airframe through the turret, changes in frequency that corresponded to speed differentials, subtle shifts that indicated when an enemy aircraft had stabilized into attack. He used a stopwatch. Reeves insisted on it, a small mechanical watch taped inside the turret where it could be seen without turning. When the bomber made a predetermined speed adjustment, the count began. When the count reached the calculated interval, fire followed. No looking back. Looking back introduced delay. Delay corrupted timing. Timing was the only thing that mattered. The idea was mocked immediately. Other crews called it blindfire. They said it was guessing dressed up as science. They said no calculation could survive combat conditions. They said the sky was too chaotic to be reduced to seconds. Reeves did not argue. He had learned in factories that people resisted ideas that implied wasted effort. If the method worked, it would prove itself. If it failed, it would kill them quickly. The first time it worked, no one claimed credit. A fighter disengaged early. Another overshot without firing. The after-action report noted evasive maneuvering and possible defensive effectiveness. Reeves added another line to his notebook. By November of 1943, Blind Faith had flown enough missions for the crew to trust the process even if no one else did. The method had not been formalized. It had not been approved. It existed entirely in the space between doctrine and necessity. On November 14, 1943, that space disappeared. The mission took them over open water north of New Guinea, where weather collapsed, depth perception, and erased the horizon. Cloud layers sat low and uneven. Visibility shifted minute by minute. Perfect conditions for interception. Enemy fighters appeared exactly when Reeves had predicted they would. The pilot did not maneuver. Maneuvering altered relative speed and disrupted the equation. He held course and adjusted throttle by a fraction, just enough to lock closure into the expected range. The tail gunner started the stopwatch. The first burst went out when the count reached the commitment interval. Not when a silhouette appeared, when the math said it would. The second followed at the overshoot interval. A third at disengagement. Each burst occupied space the enemy aircraft had not yet reached, but would inevitably pass through if it continued. The result looked impossible from the outside. From inside the cockpit, it felt inevitable. Reeves never once looked back. He trusted the numbers because they had already been tested. He trusted the vibration because it had never lied to him. By the time the engagement ended, 5 fighters were gone and the bomber was still flying. No one cheered. No one spoke. The silence afterward was heavier than any celebration would have been. They had not reacted to danger. They had anticipated it. What followed would challenge doctrine without ever confronting it directly, because proof had arrived not as a theory, but as wreckage scattered across the sea. And for the first time, people began to ask not how Reeves had fired without looking, but how often they had been looking too late. Looking too late had been the unspoken rule for years. Bombers waited for confirmation, because confirmation felt safe. Seeing the enemy meant control. It meant the fight had a shape. Reeves understood why doctrine insisted on it. Visual certainty reduced panic. It gave gunners something concrete to aim at. It made reports easier to write. What it did not do was keep crews alive. After November 14, 1943, the debriefing room at the New Guinea airstrip feels different. The same wooden tables, the same tired officers. But the questions no longer circle around courage or aggression. They circle around timing. How did the rear gunner know when to fire? Why did the pilot not maneuver? Why were there no visual corrections? Reeves answers carefully. He does not use the word blind fire. He avoids anything that sounds improvised. He talks about relative speed, about closure rates, about how fighters committed once they believed the bomber had not seen them. He frames it as inevitability. If a fighter closes at a known speed from a known distance, there is only one place it can be after a fixed number of seconds. Fire occupies that space before the fighter does. The result is not luck. It is sequence. Some officers listen closely, others do not. One points out that enemy pilots vary their approach. Reeves agrees. Another argues that vibration cannot be measured reliably in combat. Reeves agrees again. A third asks what happens if the enemy changes throttle mid-run. Reeves answers that sometimes the method fails. When it does, the crew reverts to standard defense. This is not a replacement for doctrine, it is an interruption of it. That word stays with them. Interruption. The reports go up the chain without recommendation. They describe outcomes, not causes. 5 enemy fighters destroyed, no damage to the bomber. Defensive fire effective. What makes them difficult to dismiss is that similar language appears again within days. Another mission, same aircraft, similar weather. 2 fighters destroyed without visual tracking. A third disengages early. Then another crew reports something stranger. They attempt a partial version of the method after hearing rumors. They fire early, but still look back. The result is inconclusive. 1 near miss, no confirmed kills. Reeves is asked about it privately. He explains the failure without judgment. Looking introduces lag. Lag breaks the sequence. The method only works if everyone commits to it fully. Half measures produce half results. This is not comforting to command. Doctrine exists to eliminate dependency on individual discipline. What Reeves is proposing cannot be standardized easily. It depends on trust, repetition, and restraint under stress. Still, something has changed. The enemy begins behaving differently. Fighter attacks become less aggressive on certain routes. Approaches are delayed. Probing bursts are fired from farther back. Pilots hesitate before committing to the tail. Intelligence intercepts later suggest confusion. Pilots reporting defensive fire that arrives before engagement. Tracers appearing in places that do not match bomber orientation. Uncertainty creeps in. Reeves is reassigned again, this time to a small group flying long-range patrols over the Bismarck Sea. The move is framed as operational need. In reality, it isolates the variable. If the method works only with Reeves, it will fade quietly. If it works with others trained the same way, it becomes harder to ignore. He trains the new crews without calling it a tactic. He calls it preparation. They memorize closure tables. They rehearse timing drills on the ground. Engines running, stopwatch counting. No one looks back. He insists on that rule, above all others. The first few missions are uneventful. No enemy contact. The tension builds because nothing tests the sequence. Then contact comes. The results are mixed at first. 1 fighter damaged, another disengages early, no confirmed kills. Reeves reviews the timing afterward and finds hesitation, a delay of less than 1 second, enough to let the enemy adjust. He does not reprimand, he adjusts the process. He simplifies the intervals, he removes optional steps. On the next mission, it works again. 2 fighters destroyed, no damage to the bomber. By now, word has spread beyond the unit. Not officially, quietly. Gunners talk. Pilots listen. Some try it, some dismiss it as coincidence. Command remains cautious. There is no appetite for rewriting doctrine in the middle of a war. There is also no desire to discourage something that seems to reduce losses. The method exists in a gray zone. It is never ordered. It is never forbidden. By early 1944, several crews across the theater are using versions of it under specific conditions. Poor visibility. Rear pursuit. No escort. Long over water legs. The success rate varies. Discipline proves to be the deciding factor. Reeves does not seek recognition. He continues flying until injuries and fatigue ground him temporarily. When he is finally reassigned stateside, the method does not disappear. It persists without his name attached. After the war, analysts reviewing Pacific air combat will note subtle shifts, enemy fighters abandoning pursuit earlier, increased caution during tail approaches, no single explanation offered. Reeves returns to civilian life quietly. He works in manufacturing systems. He designs timing processes, flow control, predictive maintenance, systems where reaction is always too slow He does not give lectures. He does not write memoirs. When asked about the war, he describes it as a series of problems that either get solved or do not. His death, in 1998, passes with little notice outside family and a few former crewmen. Obituaries mention service. They do not mention equations, but among those who flew with him, the lesson remains intact. You do not wait for certainty in a system that rewards commitment. You calculate when commitment will occur and act before it does. By the time you see the threat clearly, the solution window has already closed. The solution window closing was not a metaphor to Reeves, it was a measurable fact. By the time sight confirmed danger, the numbers had already moved past the point where correction mattered. That belief shaped everything he did in the air during the final months of the war, even as his role became quieter and his flights fewer. He never claimed the method was invincible. He understood its limits better than anyone. It required conditions. Prédictable poursuit. Consist enemy behavior. Crews disciplined enough to resist instinct. When those conditions vanished, the equation collapsed. But when they held, the effect was undeniable. The most unsettling part was not the destruction of enemy fighters. It was the calm that accompanied it. Crews reported less panic once the sequence began. Fear thrived in uncertainty. Timing replaced uncertainty with structure. Reeves observed this without comment. He had seen it before, long before aircraft and tracers. In factories, when machines jammed unpredictably, workers panicked and made mistakes. When failures followed known intervals, tension eased. People trusted the process. Combat was no different. In late 1944, Reeves flew his last operational mission over the Pacific. Weather conditions were marginal. Enemy contact was brief. No fighters were destroyed. The method was not used. He noted the absence without disappointment. Not every problem required the same solution. When the war ended, Reeves returned home to Akron. He stepped back into a world governed by schedules rather than sorties. Conveyor belts replaced flight paths. Vibrations traveled through steel instead of aluminum. The principles remained familiar. He worked quietly, designing systems that anticipated failure rather than reacting to it. Production lines that slowed before breakdown. Maintenance schedules built around wear patterns no one else noticed. Colleagues described him as precise. Some called him difficult. Others trusted him implicitly because his predictions were rarely wrong. He married late, raised a family, spoke little about the war. When pressed, he avoided stories of combat. He talked instead about preparation, about how most disasters were visible long before they occurred if someone bothered to measure them. Among former airmen, the story of blind faith lingered without official acknowledgement. It was retold carefully, often stripped of names, sometimes exaggerated. 5 fighters became 6. Blindfire became instinct. Instinct became legend. Reeves never corrected them. He understood that legends filled gaps where doctrine refused to look. In flight schools decades later, instructors taught predictive defense using new language. Sensors replaced stopwatches. Computers replaced notebooks. But the core idea remained intact. Anticipation outperformed reaction. Energy states mattered more than aim. Commitment was predictable. Reeves did not live to see these ideas formalized. He died in 1998, his passing noted briefly in local papers. A veteran, a former engineer, a quiet man survived by family. There was no mention of blind faith, no reference to New Guinea, no acknowledgement of a method that never officially existed. But somewhere, in training materials stripped of names and places, the principle endured. Fire into where the threat must be, not where it appears. Trust calculation over panic. Accept that seeing is often the last step, not the first. The sky over the Bismarck Sea returned to silence long ago. Wreckage settled. Water closed over the equations once solved there. What remained was not the aircraft or the men who flew it, but the understanding they carried. That control in combat came not from sharper eyes, but from clearer timing. Sometimes, the most decisive act was refusing to look back at all.